Before we begin, let me just tell you about the channel Authorn Academy. Authorn Academy is dedicated to bringing interesting lectures with solved example questions on a variety of subjects with critical concepts. For topic-based worksheets with detailed solutions, go to our website, authorn.com. If you enjoy our videos, please like, share, and subscribe. Now we're going to be solving question 4A and D of year 2015, variant 4.1, MJ question paper. So in this question, they say that silver sulfate is sparingly soluble in water. The concentration of its saturated solution is 2.5 times 10 to the power minus 2 mole per dm cube at 298 Kelvin. Write an expression for the solubility product of silver sulfate and its units. Okay, so if we were to write the solubility product, first let's write the equilibrium reaction for its dissociation. So we can write Ag2SO4 Ag plus 2 plus SO4 2 minus. So accordingly we write Ag plus for 2 because of the stoichiometric coefficient, right? SO4 2 minus, and as for the units, it will be mole per dm cube whole square into mole per dm cube, which is mole to the power 3 and dam to the power minus 9. Now in the second part, they've asked us to calculate the value of the solubility product. So we can say that ASP equals to Ag plus for 2 and so 4 2 minus. And since we know that the concentration of the saturated solution is 2.5 times 10 to the power minus 2, we can say that the concentration of the silver ions is 2 into 2.5 times 10 to the power minus 2 whole squared. And since the molar ratio of the salt and the sulfate ion is 1:1, we don't have to multiply anything with it. We can just write 2.5 times 10 to the power minus 2, and we will get 6.25 times 10 to the power minus 5 as our solubility product. So let's just write here 2.5 times 10 to the power minus 5 to the power 3 to the power minus 9. In part D, we have been told that solution of iron 3 sulfate is acidic due to the following equilibrium, and we've been given acid dissociation constant. When iron 3 sulfate is dissolved in water, it produces Fe3 plus ions and sulfate ions. So these ions of Fe3 plus tend to form this ligand over here in water. These iron 3 plus ions tend to form this ligand over here, which goes through an equilibrium reaction to form another ligand and hydrogen ions. Therefore, these iron 3 ions are acidic in nature when they dissolve in water to form a weak acid solution of sorts. So since we know that the concentration of the iron 3 sulfate salt solution is 0.1 mole per dm cube, we know that the concentration of the ion is 0.2 mole per dm cube. As a result, its ligand will also be of concentration 0.2 mole per dm cube. So the ligand formed by the iron 3 plus ions will also have a concentration of 0.2 mole per dm cube. To find the pH of the weak acid solution, we have to find the hydrogen ion concentration first. So for any weak acid, the equation to find the hydrogen ion concentration is Ka into weak acid concentration, which is 0.2 into 8.9 times 10 to the power minus 4, which gives us 1.33 times 10 to the power minus 2 mole per dm cube. So pH is equals to minus log H plus, which will give me 1.9. The pH of this solution is 1.9. Now let me just label the steps. This is the first step. This is, wait, let me use a different color. This is the first step to understand that the iron 3 sulfate salt dissolves, and then we understand that its concentration will be 0.2 mole per dm cube. The concentration of the ligand formed by the iron 3 ions will be also 0.2 mole per dm cube. And we have to understand that due to the formation of this ligand, the solution has hydrogen ions. So we can say that this is step 3. We can say this is also step 3, because this will help us understand why the solution is acidic. So then we proceed with the basic maths of pH values for weak acid solutions to find that the pH is 1.9.